Having looked at Nikhilam multiplication below the base and above the base, we'll now look at the case where we've got one number below and one number above the base. So as a first example, consider 12 times 7. Here we're going to relate both the numbers to 10, and 12 has an excess of 2, so we put plus 2. And 7 has a deficiency of 3, so we put minus 3. And now you'll see the reason for the plus signs and the minus signs, because on the right we have to multiply plus 2 by minus 3, which gives minus 6. And we write this with the minus sign on top. And that minus sign is called a vinculum. Vinculum is a Latin word, and it means chain or bond. And it has three different uses in mathematics. The first is where it means a minus number, and also it's used in logarithms, log tables, for those of you who are old enough to know how to use log tables before the advent of the electronic calculator. And then also it's used as a bracket, as in a square root sign. If you have the square root of 4 squared plus 3 squared, that brackets together all that's inside the square root sign. If it wasn't for more than one term, we would just use a tick. So root 4 equals 2. You don't need the line across the top unless there's more than one term. On the left over here, we can cross subtract. 12 take away 3 is 9. Or we can cross add, going the other way. 7 add 2 is 9. But this method uses, we need to use another line of working, because now we've got 9 in the tens column and minus 6 in the units column. So this means 90 less 6 units, which is 84. Like so. And when we move to a base of 100, say 107 times 94, we can use the same process. Here we have a surplus of plus 7 and a deficiency of minus 6. And on multiplying plus 7 and minus 6 together, we get minus 42, or winky 4, winky 2. On the left, we can cross add 94 plus 7, or cross subtract 107 take away 6, leaving 101. We then have to devinculate the right hand side, and we've got a 1 in the hundreds column, a negative 4 in the tens column, and negative 2 in the units column. So how do we deal with that? Well, in fact, we can use the all from 9 and the last from 10 rule, and reducing this digit by 1, giving a 0, we can then apply all from 9 and the last from 10 to this 4 and 2, giving 5, 8. In other words, 100 take away 42 leaves 58. So what about this vinculum? How do we put a number into vincular form, take it out of vinculum form? Well, a simple example is this. If we take 29, you can write it as 30 winky 1. And in some circumstances this can be very useful for calculations. So for example, if we wanted to work out 29 times 7, and we put it into vinculum form, 30 winky 1 times 7, then you can see the answer will be winky 7 with a 3 7s 21. And then we just have to devinculate this to give 203. And in general, we can use vinculum digits wherever, usefully, wherever the numbers are bigger than 5. So if we take the number 28697, we can turn this into vinculum form by increasing this digit by 1, giving 3, and then subtracting all these numbers from 9, the last from 10, giving 1303 vinculums. Well, winky naught. Is it a vinculum? No, not really. It doesn't matter. So if we have to devinculate, this, we reduce the 3 by 1, giving 2, and then apply all from 9 and the last from 10, to all these digits, giving 8, 6, 9, 7. So let's take another example. 1214 multiplied by 997. So here the surplus is 214, and here the deficiency is 003. We then multiply. 3 4s are 12. 3 1s are 3. 1 is 4. 2 3s are 6. Cross subtract to give 1 2 1 1, or cross add if you like, going the other way. And now devinculate this. 1 2 1 0. Drop this digit by 1, and then apply all from 9 and last from 10 to these 3 digits, giving 3 5 8. And that's the answer.